The cylinder block is the foundation around which the engine is built. It houses cylinder bores or holes for the cylinders, pistons and rings, water jackets for cooling, and oil passages for lubrication. The piston is the part of the engine that transfers the energy of the combusting fuel to the crankshaft to move the vehicle. Compression rings installed near the top of the piston provide a seal to keep pressure above the piston. The lowest of the rings, called oil control rings, prevent the oil from entering the combustion chamber, spread the oil around the cylinder wall, and scrape excess oil back into the oil pan. The connecting rods connect the pistons to the crankshaft. Connecting rods are rigid and can only transmit a push or a pull to rotate the crank through both halves of a revolution. During the power stroke, the rod transmits power from the piston by pushing the crankshaft. There are 2 lubricated bearings on each connecting rod, one at the crank end called the big end or rod bearing, and one at the other end that attaches the piston to the connecting rod. The second bearing is called the wrist pin, little end, or gudgeon pin. To start the engine, the starter motor is engaged and rotates the flywheel and crankshaft. The engine starts when fuel is introduced into the cylinders by the fuel system. This animation is of a small diesel engine, so it has no spark plugs. A diesel engine ignites the fuel from the heat of compression rather than a spark plug. The linear motion of the pistons and connecting rods rotate the crankshaft, which provides the power for the transmission and drivetrain. The crankshaft consists of main bearings for support, connecting rod journals, and counterweights to balance the rotating mass. The valve train includes valves, rocker arms, push rods, cam followers, and a camshaft. The valves in the cylinder head control air and exhaust gas flow into and out of the cylinders to facilitate combustion. The camshaft controls timing for the open-close duration. In a modern gasoline engine, fuel is injected either into the inlet manifold or directly into each cylinder by the fuel injection system. Older gasoline engines used carburetors to supply the fuel-air mixture to the engine. Diesel engines always inject fuel directly into the cylinder. Several valve train components, such as cam lobes, cam followers, push rods, rocker shafts, and valve stems, have metal-to-metal contact as the engine turns. To prevent wear on these surfaces, the engine oil must have effective anti-wear capability. Diesel engines, and some modern gasoline engines, utilize turbochargers to increase both power and fuel economy. A turbocharger uses the energy in the hot, expanding exhaust gases to drive a turbine that forces more air into the combustion chambers. This increases the engine's efficiency and power output. The turbo bearings are pressure-fed with oil from the main oil gallery. Keeping this bearing lubricated and free of deposits is critical to the reliability of the turbocharger. The flywheel stores the momentum from combustion to keep the crankshaft turning smoothly in between the engine's power strokes. The flywheel stores energy when torque is applied by the crankshaft, and it releases stored energy when the crankshaft is not applying torque.